in this video. Hello everybody, and welcome to the 50-second video on our channel. And this is going to be the second to last intro trigonometry video, because then we're going to prove Ptolemy's theorem, and after that we're going to really go into trigonometry in a little more detail. So the reason I have these introductory trigonometry videos is to prepare us for trigonometry and also the more advanced geometry theorems. So after trigonometry, most likely I'll do advanced geometry with some harder geometry proofs which use these basic trigonometry concepts, and these are also used for proving Ptolemy's theorem. So that's why I decided to do them now instead of later. And Ptolemy's theorem is slightly simpler, so that's why I decided not to do it in advanced geometry. So please make sure to like, subscribe, and hit that notification button. And let's move on to that lesson. Alright, for today, what we're going to do is we're going to be doing something pretty interesting. What we're going to do is we're going to study the law of cosines, which is probably one of the most used trigonometry concepts and geometry proofs. It's very used alongside with the law of sines and sine squared plus cosine theta is equal to 1. To show you a complete proof of the theorem, because it's always good to have the proof, and this proof doesn't rely on anything that's that complicated. So let's go into it. This lesson, of course, you know it's about the law of cosines, and the law of cosines is stated over here. Though it's the equation which I have circled. C squared is equal to a squared plus b squared minus 2ab cosine theta. Now, you might notice it looks kind of like the Pythagorean theorem, saying c squared is equal to a squared plus b squared. Now, it is actually pretty much kind of like an extension of the Pythagorean theorem, because if you plug in 90 degrees here, and if you watch my last video, you will know that cosine of 90 degrees is equal to 0. So that just gives us c squared is equal to a squared plus b squared, and that angle is the opposite angle to c. And 90 degrees is the opposite angle to c in the right triangle, because if I draw basic right triangle shape over here, we have a, b, c, and then quickly you see this is the opposite angle to c. So c is equal to a squared plus b squared. So I just like to show you that it's kind of like an extension of the Pythagorean theorem. That's really like if you wanted to get the main gist, that's what I would say it is. And this, along with the law of sines, as I previously stated, is used a lot. And this relates different angles, because in geometry, more advanced geometry, you won't always have right triangles. You won't always have right triangles like the one shown here. You'll have different quadrilaterals and everything that you might need to split into triangles. For proofs, you might need to extend lines and create triangles for geometry proofs. So it's just a lot more complicated in advanced geometry without using the trigonometry, because then it becomes really, really long, and some of the theorems are just downright impossible to prove. So let's move on into the proof of this theorem. What we're going to do is, you see the intersection between B and C. What we're going to do is we're going to draw a line that's perpendicular to side A. Let's call this side H. Alright? So we call this side H, and what we're going to do is we're going to say, okay, we want to define a few lengths. Number one, we want to know what H is. Now, if you see, we drew perpendicular for a reason, because now that these angles are 90 degrees, you'll soon realize that B is kind of like the hypotenuse, and the angle theta is just like regular angle theta. So if you see H by B is equal to sine theta, so that becomes H is equal to B sine theta. So instead of H, why don't we call it B sine theta? B sine theta. Sorry, that took a bit, but now that we have B sine theta written down, and then if you look at the final side of the right triangle, you'll see that that's equal to B cosine theta by the same logic. So if the total length of the bottom side is A, and the length of the side that's closest to B is B cosine theta, then the other part of A is equal to A minus B cosine theta. Let's erase the A really quick. So then we have another right triangle, which I'll have just a little bit red highlighted here. that has sides of a minus b cosine theta, b sine theta, and c. So if you notice that, that's a right triangle. And we can apply the Pythagorean theorem. C squared, let's write that in black, C squared is equal to b sine theta squared plus a minus b cosine theta squared. So if you do the math, which I'm just going to show in red really quick so you know it's just like basic math, and I'm just going to cut it out of the video. Alright, so if you look at that, that's after doing all the math. So we're going to start at the very last, c squared. After just simplifying the Pythagorean theorem, we get c squared is equal to b squared sine squared theta plus b squared cosine squared theta plus a squared minus 2ab cosine theta, which is just the doing of the Pythagorean theorem. So then we factor out sine b squared from b squared sine squared theta and b squared cosine squared theta to get b squared times sine squared theta plus cosine squared theta plus a squared minus 2ab cosine theta. And that becomes c squared is equal to a squared plus b squared minus 2ab cosine theta, because sine squared plus cosine squared theta is equal to 1. So that's essentially the proof and the explanation of the theorem. Thank you so much for watching. See you in the next one, and bye-bye.